finding period, block and group of an element we'll do. But before starting that, we'll do the nomenclature of element atomic number greater than 100. So we are doing the nomenclature of element greater than 100 atomic number. Atomic number greater than 100. So for 0 we'll use nil, for 1 we will use un, for 2 we will use bi, 3 tri, 4 quad, 5 pent, 6 hex, 7 sept, 8 oct and 9th in. So we will take one example, 101. For this atomic number, by the nomenclature, name of the element will be un, nil, un, and in last we have to add the em, IUM. So un, nil, un, em. For 102, un, nil, bi. But for bi and em, they both have I in end and I in starting, so we can't write two I's together. We'll write one I, then UM. Unil by EM. So this is very easy, that you can do this. You have to remember only. There's not much anything to understand. Now we'll start the finding period, block and periodic group of an element. So first of all, we'll do the block. In a single line, you can say subshell in which last electron falls. Subshell in which last electron falls. Advanced level question, JEE advanced level questions, you have to understand it very clearly. For S block elements, we'll write the characteristics. Group 1 and group 2 elements are S block elements. Then for S block elements, inner shells are completely filled. Complete. And then last electron falls in S subshell of outermost shell. In S subshell of outermost. So this last line is very, very important. You know how to fill the electrons for an element. This you will study in other chapters also, in atomic structures. In many chapters you will study that, but I'll explain it in very small. 1s2, 2s2, 2p2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14, 5s2, 5p6, 5d10, 5f14, 6s2, 6p6, 6d10 and 6f14. So this is how you have to fill the electrons. So you can write it like 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6 and 5s2, so on. This is how you have to fill the electrons. So if the electron is in the last S subshell, then that element will be called S block elements. If the electron is in 1s or 2s or 3s or 4s, then that element will say is S block element. For P block, first point, group 13 to 18, all the elements are P block element. All inner shells are complete. For P block also, all inner shells are complete. Then third point for P block, same, last electron falls in P subshell of outermost shell. In P subshell of outermost shell. So if the electron is in 2p or 3p or 4p, then that element will be P block element. Now we'll do for the D block and F block. D block. Elements in which outermost shell and penultimate shells are incomplete. Here one term is coming penultimate, that I will tell. First I will write elements in which outermost shell and penultimate shell are incomplete. N and n minus 1. If the outermost shell is 4, then penultimate will be 3. If the outermost shell is 6, then the penultimate shell will be 5. Like this. So if the electrons, if the atom's outermost shell is 5, then the penultimate shell of that atom will be 4. Next point, last, electron falls in D subshell of n minus, that means penultimate shell. So if you see for the iron, iron has 26 electrons in one atom, and electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then 3d. So in the outermost shell is 4 and penultimate shell is 3, and 3d6 is 6 can have the 10 electrons in it, can have 10 electrons, but for iron only 6 electrons are there in the D subshell, and that is also 3d, but 4s is the outermost shell. Penultimate shell is incomplete. This is the important point. There is a difference in S block and P block. In S block and P block element, penultimate shells or inner shells are fully filled. But for D block elements, penultimate shells will be vacant. F block element. Outermost shell, penultimate shell, anti-penultimate shells are incomplete for the F block element. Anti-penultimate shell means the third last shell, outermost shell, penultimate shell, and anti-penultimate shell are incomplete. N, n minus 1 and n minus 2. So if the atom is having 6 shells, penultimate shell will be 5 and anti-penultimate shell will be 4, and 4 and 5 will also be the 4 and 5 will also have the less electrons. And one more point for the F block, last electron falls in F subshell. This is true for the every block element. F subshell. and n-2 shell. Like neodymium, we'll do for the neodymium. Neodymium. Neodymium will have the 60 electrons, and electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, and 4f4. Count it: 2, 2, 6, 10, 2, 6, 2, 10, 10, 30, then 40, 48, 50, 56, and 4, 60. So total 60 electrons are there, and outermost shell is 1, 2, 3, 4, 5, and then 6. So this is the outermost shell. 6. Electrons are there for the 6 shell, and then 5 is having also less electrons, 2 and 6. D is not filled, 5D is not filled. Okay, then 4 S is filled, P is filled, and D is filled, but 4 F is not filled. Okay, so penultimate, anti-penultimate, and outermost shell all are not completely filled. Here we complete the block for the elements. Period. Largest value of principal quantum number is period. Largest value of principal quantum number is period. Outermost orbit. Or shell. So if the electronic configuration is written like chromium 4d 10 5s2, so the period for this will be the 5. Outermost shell or principal quantum number, highest principal quantum number is 5 here, so period 5. If the electronic configuration is written xenon 4f7 5d1 and 6s2, then period will be 6. Then group. For group, to find the group of an element, we have short tricks. For S block, element, first we have to know from which block this element is. Okay, then we will apply this short trick. For S block, number of electrons in outermost subshell. That will be the group for S block element. P block, for P block, 12 plus number of electron in P, here S subshell, here P subshell. That will be the P block elements group number. D block, 2 plus number of electrons in n minus 1 D subshell. N minus 1 D subshell. For F block, group will be always 3. If you get to know that this element belongs to F block, then the group number for that element will be 3 only. So for this electronic configuration, we will find the group now. Group will be, because last electron is in the D subshell. Okay, so this element is in D block element, and this element is also D block element. And group now will write group for D block element, 2 plus number of electron in n minus 1 D subshell. So total 10 electrons are there in 4D. So 2 plus 10, group number 12. For this, 2 plus number of electron in n minus 1 D subshell, 1. So third group. So here we complete the finding group, block and period of an element. In next video, we'll start with the Z effective and screening effect. Thank you.